This is part 2 of section 5.5. I want to find all solutions of each equation and give our answer in degrees this time. So I have cotangent of x is equal to 1. And this means that tangent of x is equal to the reciprocal of 1, which is just 1. Okay, so now find inverse tangent of 1. And when we're in degrees, that is 45 degrees. Okay, and then tangent, our solutions are alpha plus n pi. Instead, we're not dealing with radians, so we'll be dealing with 180 degrees. And this is our alpha. So our x values are 45 degrees plus 180 degrees n. So 45 degrees, and then I can keep adding 180 degrees over and over and over again until you have as many solutions as you could possibly want. Okay, let's solve 2 times cosecant x plus 4. I'm going to get cosecant x by itself first, so subtract 4. And then divide by 2. And I have cosecant of x is equal to -2. And what this means is that sine of x is equal to -1/2. So this is the equation I want to solve. We need to find inverse sine of -1/2. And that will give me my alpha. And we're in degrees, so this is -30 degrees. Okay, now, so this is our alpha variable. Our x values are alpha plus, with sine, it's 2 pi or 360 degrees, n. So for sine, that's our first possibility. To get our second set of possibilities, we need to do, this says pi minus alpha, but it's going to be 180 minus our alpha. And then that's going to be plus 360 degrees n. Be careful with your negatives here because that needs to be 210. 210 degrees plus 360 degrees n. So everything that is coterminal with 210 degrees and everything that is coterminal with -30 degrees. Those are all of the solutions to that particular equation. Okay. So let's find all solutions in degrees, and we're supposed to round our answer to the nearest tenth of a degree. So we're not going to have exact solutions here. Okay, so cosine of theta is equal to 0.6. First thing I want to do is to find inverse cosine of 0.6. And that is approximately 53.1 degrees. So this is the alpha. For cosine, our answers, so theta, is equal to our alpha plus 360 degrees n, or our theta is equal to, for cosine, it's 2 pi minus, so that's 360 degrees, minus 53.1 degrees, plus 360 degrees n. Okay, now this time, instead of just listing all of the solutions like our previous problems asked for, we're asked to list the solutions on a specific interval. That means we actually do need to calculate what happens with our n. Okay, so if n is 0 here, I get 53.1 degrees. And if n equals 1, then I'm going to get a number larger than 360. And that's larger than what we're supposed to be looking for in our range here. So this is the only solution I have from this possibility. Go ahead and do the arithmetic here, and you get 306.9 degrees plus 360 degrees n. And the same thing happens here. We want to plug in values of n, 0 through however many we want to make sure that we get every single possible answer between 0 and 360 degrees. Now, if I go add 360 to 306, I'm definitely outside of this. So the only possible answer I get here, again, is from when n is equal to 0. And that gives me 306.9 degrees. The solution set here is 53.1 degrees and 306.9 degrees. Those are the solutions there. Okay, so let's work. Cosecant of theta is equal to negative 4.5. This means that sine of theta is equal to negative 1 over 4.5, and that is negative 2/9. Okay, now sine inverse of negative 2/9 is approximately negative 12.8 degrees. So our first set of possibilities will be negative 12.8 degrees plus 360 degrees n. And our second set of possibilities, since this is sine, it will be 180 degrees minus a negative 12.8 degrees plus 360 degrees n. Now here, if our n equals 0, then we get negative 12.8 degrees. And we're supposed to be finding our answers between 0 and 360. So this is not a solution that works for us right now. So add, if n is 1, I'm going to add 360 to this, and you get 347.2 degrees. So that's one of my solutions. And then if I add 360 again, I'm too large. I'm out of the range we're interested in. So this is the only solution I get from this set of possibilities. Now, do your arithmetic here, and you get theta is equal to 192.8 degrees plus 360 degrees n. If our n is 0, then I get 192.8 degrees. If my n is 1 and I add 360 to this, I am outside of the range we're interested in. So my two solutions are 347.2 degrees and 192.8 degrees. Okay, let's try solving 3 sine x minus 1 equals 0. We're supposed to find all of our solutions between 0 and 2 pi and round to 4 decimal places as needed. So if we can find an exact solution, that's what we want. If we need approximations, so be it. First thing I'm going to do is I'm going to solve this for sine. And I'll end up with sine of x equal to 1/3. Add 1, divide by 3. So let's find sine inverse of 1/3. Make sure that you are in radians when you use your calculator for this, and you will get that it is approximately 0.3398. Now, for sine, our answers are 0.3398 plus 2n pi, or our x values are, for sine, it's pi minus our alpha plus 2n pi. Well, since this is a positive number, if I add 2 pi to that, I'm larger than 2 pi. So this is my only solution here. Do your arithmetic here, and you'll get that x is about 2.8018 plus 2n pi. And again, since this is a positive number, if I add 2 pi to that, I'm outside of our indicated range. So my two solutions are 0.3398 and 2.8018. And those are in radians.